Hello, myself Dr. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding design concepts of software engineering. This topic learning outcome is mapped to the course outcome of CO4, which is understand the importance and need of design and explain the various approaches of design. In this video, I briefly discussed about what is the software design, what are the basic principles that are followed in the software design, what are the objectives, and what are the basic components or elements of the software design. So, software design encompasses the set of principles, concepts and practices that lead to the development of high quality system or product. So the design document is visually represent the features or functionalities of the software to be developed. So the design principles establish an overriding philosophy that guidelines the design work. Design is pivotal to success of software engineering. So the goal of design is to produce a model or representation that exhibits firmness, commodity, and delight. Software design changes continuously as new methods. So better analysis and broader understanding must be evolved with the help of software design document. So the change in the requirement can be easily maintained and tracked with the help of design concepts and principles. So the objectives of software design is basically the correctness, efficiency, flexibility. Correctness is a good design should be correct. It should correctly implement all functionalities of the system. So different stakeholders are interacting with the system. The software design provides the accessible APIs for implementing all features or functionalities of the software to be developed. The efficiency is a good software design should address the resources, time and cost optimization issues. Flexibility is another objective of software design. So a good software design should have ability to adapt and accommodate changes easily. It includes designing the software in a way that allows for modifications, enhancements, scalability without requiring significant rework, causing major disruptions to the existing functionality. Next, objectives of software design are understandability, completeness, maintainability. A good design should be easily understandable. It should be modular. All the modules are arranged in a layers. So different levels of abstractions must be present. Completeness is the design should have all the components like data structures, modules, external interfaces, etc. Maintainability, a good software design aims to create a system that is easy to understand, modify and maintain over time. What is software design in the context of software engineering? The software design sits at the technical kernel of software engineering. So all the technical details and functionalities, features must be represented with the software design and is applied regardless of the software process model that is used. So for the development of the software, we can use variety of software process models like waterfall model, spiral model, incremental model, RAD model. So apart from this, the software design is produced the technical features of the software. Each of the elements of the requirements model provide information that is necessary to create the 4 design models required for the complete specification of the design. So the requirements model manifested by scenario-based elements, class-based elements, flow-oriented elements, and behavioral elements to feed the design task. So these 4 elements are the foundation or building blocks of the software design. So from the analysis model, the requirements are analyzed and are documented in the SRS software requirement specification. So from these requirement analysis, it is converted into the design model. So here the design model generally converted into the data or class design, architectural design, interface design, and component level design. With the 4 requirement model elements, those are the scenario based elements, flow oriented elements, class based elements, and behavioral elements. So how to translate this analysis model into the software design? Software design is the process of transforming user requirements into suitable form, which helps the programmer in the software coding for implementation. During software design, the design document is provided based on the customer requirement as documented in the SRS document. So based on these requirements, the software design document is created by using variety of case tools and UML tools. Hence, this phase aims to transform the SRS document into the design document. So based on these 4 fundamental elements of the requirement model, the design must be created. One is the scenario based element, second one is the class based element, third one behavioral element, fourth one flow oriented element. Scenario based elements. Using a scenario based approach in the software design, system is described from user's point of view. How the stakeholders are interacted with the system is concentrated in the scenario based element. For example, basic use cases and their corresponding use case diagrams evolve into more elaborate template based use cases. So users and are represented as actors in the use case diagram, and system functionality or features are represented with oval shape. So how these users are interacting with what part of features must be represented clearly with the help of use case diagram. So another diagram in the UML that will help for scenario based element is the activity diagram. So UML activity diagram for eliciting requirements and representing them using use cases. Therefore, 3 levels of elaboration is possible in the scenario based elements. Consider an example of use case diagram of ATM. So here the use case diagram provides the basic interaction of the stakeholders with the software. Here majorly 2 notations are used. The users must be represented with a stick figure and the use case is represented with a oval shape, and here the use case name must be represented. So these are the functionalities or features that are represented by the software. So here 3 users are present: customer, technician and bank. And the functionalities that are provided by the bank ATM are check balance, deposit funds, withdraw cash, transfer funds, maintenance, repair. But the technician is limited to access the functionalities of maintenance and repair. The bank has the full access to all functionalities. The customer is limited to access the major transaction functionalities of checking balance, deposit funds, withdraw cash, transfer funds. So like with this diagram, how the stakeholders can involved in performing variety of functions or features of the software. Another diagram that is used in scenario based elements is the activity diagram. Consider an example of activity diagram of ATM. Here this is representing the starting point of the ATM system. The user first must log into the system, and after login successful, then only he can access the features of the banking software. So here he can update the drive location, show the map, and location based access can also be used while accessing the ATM. So depending upon the location, the wait for actions must be there, and what type of action the user want to do, whether to develop drones to be flight or remote flights must has to be used. So here after that, what the transactions that the user must be proceeded, the condition based approach can also be represented with the help of activity diagram. It generally produces the list of activities that must be executed during the transaction. Another elements of the requirement model is the class-based element, a collection of things that have similar attributes and common behavior are the objects and categorized into classes. So here the class must be represented in the UML with a rectangular box with 3 compartments. The first compartment represents the class name. The second compartment represents the data. The third compartment represents operations or methods. So, in addition to class diagram, other analysis modeling elements depict manner in which classes collaborate with one another, and relationships and interactions between the classes are modeled in the class-based elements. So consider the example class diagram of the ATM. Majorly, ATM class diagram consists of 5 classes. And each class can have 3 compartments: the class name, the data upon which the class operates, and the operations. Consider here ATM card. Here the second compartment can consist of the data, and the third compartment is representing what operations that must be performed. So here and one more class you can consider, that is the account. So here also the second compartment represents the data, third compartment represents operations or methods performed over that class. So these classes must be related with relationships. So the top 2 classes are related with association relationship, and the this class and the bank details, bank customer must be dependency relationship can be used to connect these 2 classes. So the class diagram represents how many number of classes are present in the software and how they are related. Next set of elements are the behavior elements. So, effect of behavior of computer-based system can be seen on design, that is chosen, and implementation approach applied. So, during runtime, how the software can behave is modeled with the help of behavioral elements. Modeling elements that depict behavior must be provided by requirements model. So method for representing behavior of a system is with the help of states and events that cause system to change the state in the state diagram. So the basic UML diagram that can be used for the behavior elements modeling is the state chart diagram. A state is an externally observed mode of behavior. So consider the example of state chart diagram of ATM. The state can be represented with a rounded rectangle. And this point is the start of the state diagram, and this notation is the end of the state diagram. And the state must represent the state change or transition can be occurred when an event occurs. So during runtime, how the states must be changed is the behavioral modeling is exemplified with the state chart diagram. When the ATM is idle, the card is inserted by the customer. This is an external event occurred. The card must be paid, and the card paid successfully. Then pin entry, the next state card paid to the pin entry state is changed, and bank verification is successful. So that the pin entry, as soon as pin entry verification state, the ATM and pin is verified, the session next and returning to the card. So if it all during execution, how the software behavior is represented with a series of states and the occurrence of events is modeled with the help of state chart diagram of ATM. Another diagram that is helped for the behavior modeling is the sequence diagram. The sequence diagram is represented the sequence of activities to perform a transaction with the objects by message passing. So here these are the objects: user, ATM, consortium, bank are the objects. Each object has a lifeline, which is the dashed vertical line. So during the lifetime of an object, how the messages must be transmitted with other objects in order to perform a transaction in a sequence is modeled with the sequence diagram of ATM. So user display, the ATM displays the main screen, then the user is inserting a card and the ATM requests a password. User must enter the password. Then the ATM verifies with consortium. Verification of account is carried out. And the consortium verifies with the bank the user details. And if the bank account is valid, then invalid, then bad account. The bad account message is sent to the user. So like this, the sequence of activity that can be performed during transaction execution between the objects through message passing is modeled over the lifetime of the objects in the sequence diagram. Another elements in the software design are flow-oriented elements. As it flows through a computer-based system, information is transformed. The system expects input, applies functions to transform it, and produces output in a various forms. Input may be a control signal transmitted by a transducer or a series of numbers typed by the human operator or a packet of information transmitted on a network link. A voluminous data file retrieved from the secondary storage. So the input may be variety of forms. The transform may comprise a single logical comparison or a complex numerical algorithm or a rule or sequence based for an expert system. So the flow-oriented elements are easily modeled with the help of data flow diagram. The overall flow of a system is easily modeled with the help of data flow diagram. Consider an example of data flow diagram of ATM. Here the basic notations that can be used in data flow diagram is the rectangle, which is used for representation of external entities, and the oval, it is used to represent the process. How these stakeholders are external entities is interacting with the system is modeled with the data flow diagram. So here the client and bank database are the external entities. ATM is the process. So the client must insert card pin code so that the ATM can verify the details and act accordingly. So what is the input that is given to the process? How the information is transformed is easily modeled with the data flow diagram. Then these requirement model 4 elements are the basic foundation for the 4 elements of design model. So the data are class design element, architectural design element, interface design element, component based design elements are the major foundation for the design model. So the data or class design transforms class models into design class realizations and the requisite data structures required to implement the software. So the data upon which the software operates is majorly emphasized in the data or class design. Another element of the design model are architectural design. This architectural design element defines the relationship between the major structural elements of the software. The architectural styles, design patterns that can be used to achieve requirements defined for the system. Variety of architectural styles are available like call and return architecture, centralized architecture, client server architecture. So, depending upon this architecture, the design patterns that are appropriate for the software must be chosen, and the constraints that affect the way in which architecture can be implemented. The third element of design model is the interface design. The interface design describes how the software communicates with the system that interoperate with it and with the humans who use it. So the component level design transforms structural elements of the software architecture into procedural description of the software components. What are the data or class design? The data design is the software engineering process that involves defining data structures and the relationship between data in a system. So it is considered the first and foremost important design activity in software engineering. The components of data design are data structures, data model. Data structures are the containers for storing data in a specific way, like stack, queue, linked list, etc., and indicate how data items are related, stored, and operated. Some examples of data structures include hash tables, linked list, stack, queue, trees, and graphs. The data model is the blueprint or roadmap that helps to understand data stored in a system. Like network model, hierarchical model, variety of data models are available. The components of data design are data-oriented design, data abstraction, apart from the data structure and the data model. So the data-oriented design in the software engineering approach that focus on data and the central point of an application. So, the programming prioritizes the data organization, performance optimization and scalability are focused in the data-oriented design. Data abstraction. Programmers can use abstract classes and interfaces to create a set of methods for working with a data structure. This can help to ensure that individual pieces of code can be updated or added independently. The architectural design is the specification of the major components of the system, their responsibilities, the properties and interfaces, the relationships and interactions between them are modeled with the architectural design. In architectural design, the overall structure of the system is chosen, but the internal details of major components are ignored. Various architectural design issues are gross decomposition of the system into major components, allocation of functional responsibilities to the components, component interface design, component scaling and performance properties, resource consumption properties, reliability properties are concentrated. Communication and interaction between components are greatly deal with the architectural design. Next is the interface design. Interface design is the specification of the interaction between a system and its environment. This phase proceeds at a high level abstraction with respect to the inner working of the system. So, the design problem statement produced during the problem analysis step should identify the people, other system devices which are collectively called agents. Few interface design issues are precise description of events in the environment or messages from agents to which the system must be respond. The external stimuli messages are greatly concentrated in the interface design. Precise description of events or messages that the system must produce. So, the user interactions are concentrated in the interface design. Specification of data, formats of the data coming into and going out of the system. Specification of ordering, timing relationship between incoming events, messages and outgoing events and outputs are greatly impact in the interface design issues. Next element of the data design are the component level design. Component design is the type of software design and architecture. Component-based architecture focused on breaking the software design into small individual modules. The component design describes the communication, interface, algorithms, and functionalities of each component regarding whole software design. The benefits of this component design is that makes it every module reusability, and it is also reduces cost and reusable depending upon the reusable code, and more reliable as the client gets the interaction with the system with each module, so it increases the reliability of the entire system. The component design makes the system easy to maintain and make changes in the entire system are easily adaptable, and the component design describes each component functionality more clearly. So, the component design view generally consists of three views. One is object-oriented view, second one conventional view, third one process-related view. In the object-oriented view, The modules consisting of a set of classes or objects with some common properties and functionalities. In the conventional view, the module acts like a functional part of the software, which means it is responsible for processing all logical internal operations according to the designated task. Process-related view. The process-related view uses pre-existed modules for the creation of new modules. Databases and libraries are used to store pre-existed modules. The best example of component design can be modeled with the component diagram. It is example of component diagram of online shopping system. So how these components, the modules are the subsystems, 4 subsystems are there, how they are accessed with the interfaces is modeled with the component diagram. So the importance of the software design is place where quality fostered in the software engineering. Design provides representation of software that can be assessed for quality. Design is only accurately translate a customer requirements into a finished software product or system. The characteristics of software design is it must implement all the explicit requirements contained in the analysis model and it must accommodate all the implicit requirements desired by the customer. The design must be readable, understandable, guide for those who generate the code. Majorly, the software engineers can use this design documentation for implementation. And for tester also it is a valuable document subsequently support the software development. The design should provide a complete picture of the software addressing the data, functional, behavioral domains from an implementation perspective. So the basic principles of software design is it should be traceable to the analysis model and the design should exhibit uniformity and integration. The design should be structured and accommodate change. The design should be assessed for quality as it is being created not after the fact, and the design should be to accommodate unusual circumstances. So, in this video, I discussed about what is software design, what is its important, what are the basic principles, objectives, characteristics of software design, what are the basic fundamental components of requirement model, how they can be translated into software design with variety of UML diagrams are discussed in this video. And the references used in this video are these. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.